YouTube, Troystarz. Check it. Back again with the oil sample video on my about my Volvo truck, my 2013 VNL or VN 780. That is the bigger bunk D13 engine.
For more videos like this, please subscribe.
I was running this oil that I use. You already know I use Amsoil in my truck, right? I was running this oil for 45 or 43,000 kilos. That's what I run on this oil. 43,000 kilos I run on this oil. Now, what I'm about to tell you guys is I'm going to do another oil sample. Reason being, the oil that is in my truck right now is not Amsoil. The reason for that, like I show you guys, there was a special going on when I went at the dealer. There was a special going on, $325 for everything, filters and all that, and you know, the oil that they use. I'm gonna tell you what that oil, I'm gonna put it on the screen. I don't remember the name of the oil that they put inside my truck right now. I'm gonna do a quicker oil sample on this oil that I recently get because I don't know nothing about this oil, to be honest. I'm gonna do another oil sample on that oil just to compare what's going on. I know how many kilos that oil went in on. I have all paperwork to tell, but I'm going to do an early oil sample. I'm going to do 2 oil samples on this oil. One is to know exactly what is going on with the oil already, and the next one is going to be, well, the first one is going to tell me how much time I have running this oil, and that's what I'm going to get into with this video. I'm going to call a friend of mine that have more knowledge about everything that is going on, all the particles, what everything meant, because trust me, I'm learning. I didn't know what most of those stuff meant, but this person here is the same guy that introduced me to Amsoil, and so far it's going on fine, right? And also, you know a lot about oil samples and stuff like that because he advised me before to go get an oil sample done, but which I didn't do it, you know, didn't have any time. When I finally do it, I call him to get more information on what's going on. It's all there, but there's a lot of stuff myself didn't understand. I know it, I see it, it's there in words, but I don't know what it's for. On the listing that I'm going to show you guys, right? On the listing, there is names of the particles that is inside the engine, right? And when I mention particles, it's coming from the iron and aluminum and coppers and whatever. No, all these iron and aluminum and coppers and stuff like that, every single particle, part of the engine, it's coming from. For example, say mention copper, right? And the copper is have to do with the rings or the pistons or whatever. So every single, the piston have its own particles. The sleeve got something else. We already go over this, so I know. But I'm going to go back over it and get down into detail so we can all have an understanding what is going on and how this thing does work. You know what I mean? So thanks for tuning in. Like I said, I'm going to call him right now, see if he have time for us, and we'll get this thing done. Troystarz. Call him up right now.
Hello.
Hey, what's up, man? It's Troy.
Oh yeah. It says Kentucky.
Yeah, I know. It's my US number.
Okay.
Yeah. Do you have any time, or you're busy?
Yeah, okay. I have a couple of minutes. So you're down in the States there?
Yeah, I'm currently at the border to come across tomorrow.
Okay.
Yeah, so I just.
So you're at the Canadian?
Yeah. Yes. That's where. Yeah.
Whereabouts?
Windsor.
Okay. So that's the typical crossing, Windsor. Detroit, Windsor. There, they have the big bridge there.
Yeah, the Ambassador Bridge. Yeah.
Yeah. So yeah, okay. Go ahead. Now you wanted to talk about the.
Yeah, I want to go over the oil sample again. Like,
yeah.
I want you to like tell me what these what the irons are coming from, and the silver and all that.
Okay, so just a second now. Let me see if I can find the report here. Okay, what's your email address that you'd be going under?
It's Troystarz.
Yeah, okay, I got it.
Oh, you found it? Okay.
Yeah. Okay. So start wherever you want.
Okay. Well, it's when it said the recommendation, it is telling me exactly like when I should come back to do another test again.
No. The recommendation is, let's say, the oil parameter. Let's say, for example, we're measuring in parts per million. Okay. So we take 1 million parts of water or 1 million parts of oil or 1 million parts of whatever the liquid is.
Yeah.
And then we're putting in substances, be it dust or earth or wood or anything that's foreign that didn't come with that product. So they have motor oil, and anything that didn't come with that motor oil when they made it, okay, we're measuring how much of that stuff you have. And because, so we're using parts per million, so we take the liquid and we can separate, let's say, a cup. Let's say you take a cup. Do you work in ounces or do you work in metric?
Metric. Yeah.
Metric, okay. So let's say you take a cup of 100 milliliters, okay, of liquid, and you divide that 100 milliliters into 1 million parts, okay, into 1 million little droplets, okay?
Yeah.
And then I put something into that liquid, that whatever you put in that cup that you bought, let's say it's grape juice or water or motor oil, okay? I introduce something that it didn't come with, okay? I can count how many particles of that stuff is in there that wasn't in there when you bought it.
Okay.
So let's say I have 100 milliliters of water. I divide it into 1 million little micro droplets.
Okay.
Then I have a machine that can measure the same size little particles, okay, as the divided little droplets of water. So now I say I've got 50 parts per million droplets. So in that 100 milliliter cup that you have, I've got 50 dots or 50 particles of dust in the 1 million droplets of water.
Okay.
So now I'm looking at, let's say, metal from the piston ring. And the piston rings are typically coated with chromium because it's a very hard material that doesn't wear out.
Okay.
So we wanted to slide, because, the pistons are going up and down. The rings are very thin, flat surfaces. They're maybe 1/8 of an inch high. They're a couple of millimeters, and it's going up and down, and the motor oil is separating them from the wall of the cylinder, which is typically iron or steel in the engine.
And that would be the sleeve?
Yes.
So the iron is the sleeve?
Yes.
Okay.
So we know that's iron. We know also there's iron if you don't have sleeves, that the engine block is iron typically.
Okay.
And then we know the chromium is the rings, and we know the pistons are aluminum, and we know the engine bearings have a soft coating like some tin and lead and zinc, and so we call it Babbitt.
Okay.
So what you're going to do is what they do for recommendation is they have the allowable operating parameter. So you are allowed, if your engine is running well, and you test your oil, and the number of particles per 100 milliliters, for example, just as in theory, we're going to use that as a measurement.
Yeah.
I don't know what they're using, could be a liter, could be whatever, but they're dividing it into 1 million, and they're measuring how many particles in that 1 million particles of liquid, how many particles of chromium or iron or zinc or lead or Babbitt or silicone from the gasket or whatever is in there.
Okay.
And there's a certain limit that you're allowed. If you're over that limit, this is where you use this as a tool, because now this tool is going to tell you, you operated for, let's say, 200 hours.
Yeah.
And they're saying you could go 400 hours with this oil. So now you check the oil at 200 hours to see how it's going. And now one of your parameters is out of range. You've got too much.
Okay.
So now you know what that material came from, because we know what that material, what part of the engine it came from.
Okay.
So now what we're going to do, we're going to see how much is it over. Like if you're allowed up to 50 parts per million and you're at 200 parts per million, well, now you better go in there and see what's wrong, because something's going on in there. and you don't hear it, you don't feel it, but maybe one piston is bad or whatever. So this is where it becomes a tool. So what happens is when they're going to check this and they're going to look and they're going to say that, okay, you're allowed to have 50 parts per million and you've only got 10, okay, you're well within the range. You can continue to work. You can continue to go, okay?
Yeah.
And so their recommendation is yes, continue, or no, do not continue.
Okay.
Or take a sample in, let's say, 10 days. Because typically when you put in your oil sample, you put in the number of hours the engine is run, or the axle or differential or transmission is run on this fluid, okay? So they see that if you're running like 10 hours and you accumulate so much, if you continue to accumulate the particles at the same rate, like let's say you did 100 hours, you got 50 parts per million of iron, they could figure that in if you double that, you'll get double the number of particles.
Yeah.
But that's not always true, because you could have started off with no problem at all, and then when you got halfway through to where you were going to do your test, all of a sudden something started to malfunction. But you have very little in there. There's like nothing. See, that's because the oil wasn't there long enough. See, because like I say, iron, you're allowed.
Where are you looking at?
Well, let's say we go to iron.
Yeah.
So iron, you have 34, you're allowed 100.
Okay.
Chromium, you're allowed 20, you have 1. Nickel, you're allowed 2, you have 2. So you're at the max, the limit for nickel, but still it's not a lot. Aluminum, you're allowed 20, you're at 7. Lead, you're allowed 40, you're at 2. Copper, you're allowed 300, you're at 5. So the oil's like, there's nothing in there, you know, it's like no problem.
What is the copper? Where the copper comes from?
Copper would be the main bearing and rod bearing, or it could be from the heater or radiator. But it's not supposed to get into the motor oil because the antifreeze is going through there. So typically copper would be gasket, could be a gasket. The head gasket could have copper, or it's part of the bearing material for the crank or the rods. They use an alloy where they have layers.
Okay.
There's a copper layer and then a zinc layer. The bearings are soft, but when you get these particles, these small particles in the oil, instead of scratching the polished journals of the crankshaft or that, they sink into the soft surface of the bearing, and the bearing surface absorbs any of these particles that the filter didn't get out. Okay. Because the filter's not fine enough. Don't forget, your filters don't remove everything, eh?
Yeah.
They only remove some of the stuff, but not all of it. And the thing is, they're multi-pass filters. So in other words, your motor oil keeps going round and round and round through the filter. But your air filter is a single pass. That means the dirt goes in, the air goes in one time, and it never comes back again. It gets burned and it goes out the back, or the tailpipe. But when you're talking about motor oil doesn't, you don't burn it and then it's gone. Motor oil, it keeps going from the oil pan to the pump, to the filter, to the engine, and back to the pan. So the more times it goes round and round, the more times it's exposed to the filter, the more chance the filter has that if it doesn't catch it on the first pass, it'll catch it on the second or third pass, the particle. But the air filter doesn't have that luxury. The air filter, the air goes through one time and that's it. If it doesn't catch it on the first time, too bad. And that's it. And so you might see some stuff in there like here, boron, or let's see here, they have silica. In the oil, this could be from sand getting through the air filter, because fine sand does get through the air filter. It doesn't do 100%, And then when you go down into the fluid condition, those are substances in the oil chemistry. Okay. So sodium, there's 3% or 3 parts per million. Boron, it says 250. There's less, but there's like 1. Then when you go to calcium, that's an anti-friction agent. So calcium, they say they allow 3,000 parts per million, and you have 2232 particles of that.
What is calcium?
It's a lubricant.
Okay.
Because the motor oil itself, it's a bit slippery.
Fluid condition is the motor oil.
Let me see what they call it. Yeah, it's fluid condition. That's the condition of you might be checking fuel, you might be checking lubricant, you might be checking antifreeze. So whatever it is you're sending them, that's the actual stuff you're testing.
Okay.
So what they're telling you is what the condition of certain parameters are of that particular substance, whether it be a lubricant or a coolant or a transmission oil or a diff oil or an engine oil or whatever kind of oil you're sending them. There's certain basic parameters and certain additives that they put in there, because the oil itself cannot do the job without these fortifiers. So there's calcium, lithium, zinc, and molybdenum, all kinds of stuff they put in there to separate the moving parts under pressure and heat and speed. That's what they're for.
Okay.
So that's what they do with it. It's called an additive package, and it usually comprises between 10 and 20% by volume. So if you have 1 liter of motor oil, 10 or 20% of that liter of oil will be these additives that fight corrosion from the water, because the air that's coming into the engine always has water in it. When your engine compresses to burn the fuel, the water comes out of solution when you compress. And then it gets into the engine, it gets into the air, it causes sludge and varnish. So if you're running in a very humid environment and the air has a lot of humidity in it.
Okay.
So let's say you did 10 days and everything's running great, and on the 10th day something went wrong, and all of a sudden you start to have a lot of wear, and now you take the sample and this particular metal shows very high. So
Okay.
when did the problem start? We don't know that. So if you want to find out, what you do is one of two things. You either take the component apart, be it a transmission, engine, differential, whatever. You either take it apart and look for what's worn out, or you can change the oil, put fresh, and do a test in, let's say, half the duration. So let's say you were doing your test every 30 days. Now you'll do your test in, let's say, 10 days.
Okay.
And see what happens. Now, if it continues to be high in 10 days and it's even higher than the other test you did in 30, it means it's wearing at an even faster rate, because if it took you 30 days to accumulate that much junk,
Yeah.
now in 10 days you've got even more than the 30-day test. The wear is accelerated and something's wearing very quickly.
Okay.
So now you go in there and you find out what it is. And this is where this saves you a lot of money, because the $25 or $30 like Caterpillar charges for the test, that's nothing compared to what it's going to cost you if you have a total failure of an engine or a differential or a transmission, because then it'll destroy itself and you got to replace the whole unit, and that's a lot of money. But if you take it apart, you only have to replace 1 or 2 parts. That's a lot cheaper. And another thing, you don't get stuck on the road, because when you get stuck on the road and you're loaded, now your load's late, they may penalize you for not showing up. A lot of companies guarantee the load will show up on time or they pay the freight. But if you're doing just-in-time delivery because it's manufacturing, the customer that has to get the load, they're really not happy if a whole bunch of people are waiting at the factory to put something together and they have no parts to work with.
Okay.
So you don't want it, and you're running an older truck.
Yeah.
So when they hire a broker, they don't want the broker to have an old truck, because the new trucks break like the old trucks break, okay? It doesn't matter. But the thing is, they want you to have a truck that's in good condition, as you know. So the way to do this is to do your oil analysis. So let's say it costs you $100 a month to do the analysis. You do a few tests. You do your differentials, you do your transmission, you do your engine, you know?
Yeah.
And that's 4 components. It's about $25, $30 each component. And you keep an eye on it like that. So what happens when they do a recommendation, they're going to say, okay, he did 10,000 kilometers on this oil or 20,000 kilometers on this oil. He doesn't have too much wear metal in there of any sort or of this particular sort. And the chemistry is good, like it's not too acidic. or there's not too much, or the viscosity, because they check the viscosity of the oil, because when it's exposed to heat, it thickens. When you have fuel contamination, because one of your injectors is no good, the fuel will dilute the motor oil and thin it, so it doesn't protect as well. Also, the test will show fuel content. The test will show antifreeze, okay, if there's any in there, that you can't see anyway when you pull the dipstick. So it shows you all that. You have a bad gasket, a crack in the block, whatever, that the oil, that it's getting into the oil. So all of these things you see. So when you're running an older truck, you want to be doing your tests more frequently, because you don't have any warranty on that truck. I mean, if the guy just did a liner kit or something on your truck, he's going to guarantee it maybe a year. But even then, when he did it, how do you know he didn't make a mistake and something wasn't done right? So when you have an older truck, in order to, like, if you have a new truck and it breaks down, okay, it's just as bad if an old truck breaks down. The only difference they're going to say is, oh, the guy had a new truck, so it's not his fault. But when you have an older truck, they're going to say it's his fault because he didn't do his maintenance. When it's a new truck, it's got factory warranties, so they're going to say, oh, that happens and that's okay. So you're in more trouble when it's an older truck than a new truck. That's what I'm saying.
Yeah.
So this is a tool for you to check your truck. So when your mechanic does something on your truck, like he does engine bearings or something, it's difficult to set up the bearings properly. It takes a lot of skill to set that up right. So let's say he didn't get a bearing straight or something and it starts to wear badly, but you don't hear any noise yet. At least when you're looking at your wear metals, you're going to see a lot of metal in the oil, which you can't see with your eye, of course, but the test will show it. Then you can say, okay, I better go and get some help here, and see what's going on. And then you go back and see the guy and say, look at my report. And then, okay, let's change the oil. I'll do another 5,000 kilometers on it. Let's see what it gives me. You do the 5,000, the oil's got nothing in it. Okay. You do the 5,000, the oil's got just as much junk in it. Well, you better open that engine and find out what's going on before you have to call a tow truck. So this is a very important tool. It's like an X-ray. You could see things that you can't see with your eyes. That's what it's for. So when they make a recommendation and they're looking at that, they're guesstimating. So the more you do oil samples, when they issue a report like this, they're going to look at your past samples, how far you went on those samples. They're going to say, okay, typically he drives 20,000 kilometers between oil changes, and the oil's always good. And this is the amount of metal he has in there, which is acceptable. They're going to say recommendation, keep driving for another 10,000 kilometers. Or they're going to say recommendation, change it. Now, what they like to do, they like to err on the side of safety. So if you're, let's say, 10% away from doing an oil change, they'll tell you to do the oil change as the recommendation, because you're only 10% away, because it's showing like deterioration of the oil and wear metals and viscosity is high and this and that. But in fact, if you wanted to, you could run that extra 10% and then you could test it again. And maybe it's going to be good still, the oil, and you could keep going. And this is how you learn how that oil works for you in that piece of equipment. That's how you do that. And then you also see trouble coming. So they do this on the aircraft all the time because you don't want the planes falling down. So they do this, and they have a tremendous amount of oil in the jet turbines and in the hydraulic system in those planes because they're big. So it's very expensive to change the oil. And it's useless to change the oil in a piece of equipment if you have a problem, because eventually it's going to fail on you. So what you want to know is when you need to change the oil and for what reason you need to change the oil and when is the problem coming. That's what you're doing with this, okay? It's called predictive maintenance, and it permits you to predict. So after you predict, then you do the prevention. That's called preventive maintenance. So you use the predictive maintenance to govern your preventive maintenance. That's how it works. So when it gives a recommendation, now they don't know you much because you only did one test. So to do a recommendation on one test, it's really not possible. The only thing they can do is say, this is good, this is good, this is good, keep driving, don't change the oil. That's what they're going to do as a recommendation. Then when you do your second test, If it's good at this mileage, you stretch it, because now look, this oil is like new, so it shouldn't have been changed. But, you didn't have a choice, and anyway, you changed it, got your information, and everything was good, so that's a good thing. So the next time when you have control over it, go farther and look at what they're recommending, because nowadays, everybody's recommending drain intervals that are much longer, even on the passenger cars. They're going 15,000 kilometers, 20,000 kilometers. I've been doing that for years. But I mean, they're starting to say that from the factory because, number one, they're trying to reduce pollution, and the oil is better, and the way the engines are designed is different. So this is what it is. So what this is a tool to save you a lot of misery and grief from breakdown. It will tell you if your mechanic did the proper work or not, because after he does the job, you can monitor what's going on in that engine. And then after that, be able to stretch your drain interval. And then you have a history. And as you do your oil analysis, typically most of the companies on the form, it'll show you like up to about 5 consecutive tests, one after the other. And it shows a graph with the line going up and down as the performance goes. So if you see that you're good at 20,000 K all the time, now you don't change the oil if you do a test at 20 and it says it's good. Now you go to 30. If it says it's good at 30, you do another 10 and you check it again, but you don't change the oil because you're only paying $25, $30 for the test. But the oil change might cost you $300 or $400. But even if you spend the $300 or $400, you're still not saving your life with that, because the oil test will save your life and your truck, and that's the difference. So there's no trend right now, you see. So see contamination, light fuel dilution occurring. No other contaminants were detected in the oil. The fuel, you have less than 5% fuel. The ASTM, that's the American Society for Testing and Materials. Fuel, you have less than 5%, which is very little. Glycol, which is antifreeze, you have nothing. Soot, you have less than 3%. The soot is abrasive and it causes wear. This is from poorly burned fuel. Sulfation, you have less than 30. Emulsified water, you have 0.2%. And the water you get when you shut down and the engine cools and there's humidity in the air, the water condenses out like droplets in there. And then you start the engine and the oil circulates around. It picks up the water droplets. So you have like less than 0.2%. Less than 0.2 of water. So that means the engine's running well. Now let's see here. Yeah. So I'm looking on the test at the bottom, and it says here like copper in parts per million. And
go there. You said copper. Okay, yeah. That's in the section, where section, right?
Yeah. Well, down at the bottom, that's the second page. The second page, you got these horizontal lines.
Oh, where the colors are? Yeah.
Yeah. So you have yellow and red, eh? So it says here copper 350 parts per million, and it says severe and abnormal. So red is severe and yellow is abnormal. So abnormal is not as bad as severe. So then copper, you would need around 350 parts per million. So let's go up to see what you got for copper here for the wear metals. So fluid condition, contamination. So let's see, soot nitration here, copper. So copper, you have less than 330 parts per million, okay? And you only have 5 parts per million. You see, if you look at the column, it says current. Okay, you see, it says current, and it's got some green lines around that column.
Hold on, let me get it right. Where it said current?
Well, you go right to the top, right to, okay? Mm-hmm. So you have one column that it tells you what you have, which is circled in green.
Okay.
Okay. Then you see beside the current is history 1 and history 2. Okay. Well, when you do your next test, if you use this lab, the test we have now will go into history 1 column, and the current will be the one you just sent in. When you send in the third test, the first test will become history 2. The second test, the last test will become history 1. The oldest one will be history 2, and the current one will be current. So now we look down there, and let's say we want to take iron. Okay, so iron you're allowed less than 100. You've only got 34. You're only at about 30%. So that oil, so you have no wear reading. So you have to run that engine longer with that oil before you find out, because you didn't run it long enough anyway, because nowadays they're changing oil in highway trucks at like 75,000 kilometers. So you didn't go very far. Then chromium, let's say for the piston ring, you're allowed more than one. Sorry, you have more than one, but you're allowed here less than 20 and or greater than 20, but you have less than 1 part per million, so you have no chrome in there. Then nickel, you're allowed less than 2 or less, and you only have 2, so you're pretty well at the line. Titanium, you have nothing because there's probably none in the engine. Silver, you have nothing because there's probably none in the engine. Aluminum, you're allowed less than 20, and you've only got 7, so you're about 30% there. Lead, you're allowed less than 40. That would be bearings and that. You've only got 2 parts per million there. Copper, you're allowed 330, and you've only got 5. That usually comes from the radiator or heater core. Tin, which would be in the main bearings of that, you've got 50, and you've got no tin at all. You've got no vanadium, so you've got none of the.
Okay.
So
what
yeah.
What?
Well, nickel would be in the piston rings, because nickel, they usually use chromium nickel alloy. It's very hard, so they use that for the piston rings.
Okay.
So that would be an alloy. An alloy means they mix metals together to make an alloy, which is a recipe. Like you want to bake a cake, for example.
Yeah.
You mix all this stuff together to get another result. So when you want a certain type of metal with a certain hardness and resistance to wear, you mix different metals together to get it. It's called metallurgy. So the metallurgist, he mixes in order to get a certain hardness and characteristic that they want. So that's who does that. So
what lets the nickel wear like that? Chuckling or?
Well, that's normal. When your piston is going up and down there with the oil, you can't have 100% no wear, you know?
Okay.
So when you start the engine cold, there's no oil there because it runs down when the engine is hot and you shut it off, the oil runs down. So when you start, your engine's pretty dry. So that's why they tell you 80% of your wear occurs when you start the engine, because it takes time to get the oil up. And when you shut your engine down, it's very hot. So the oil is very fluid. So it runs down and everything goes dry. So by the time you get the oil up, that's why when you start your engine, you don't rev the engine when you start it. You just start it and let it idle and let the oil come up. Because if you rev it, now you're forcing it, but the oil's not there yet. It's all down at the bottom. It takes time to pump it. And the other thing, if it's winter, for example, the oil is thick like molasses. So it's hard to pump. It takes time to get up and do the job. And on the cylinder walls, they sometimes have a spray device that sprays oil on it. Because those cylinders are long in the trucks. It's not like a car where it's short. So they spray oil there. So when the oil is thick and heavy, I can show you. Because if you get the test pump, like I'm telling you, you're going to have to get to pull your samples there, you'll see when it gets to be daylight today in Montreal, where 45 degrees or 41 Fahrenheit, you can't pull that oil with the pump. It won't go through the plastic tube. You have to start up the unit and warm it up in order to get it to pull a bit. It's got to warm up a bit. So when you start the engine, the plastic tube that you're using to suck the oil out of the dipstick tube, it's a little plastic tube that goes on a pump, a hand pump. That's about the size of a lot of passages in the engine.
Okay.
Now, it has a powerful oil pump, the engine, okay? But it's still hard to push the oil. And there's a pressure relief valve there. Because when you're trying to force there, if the pump has trouble doing it, there's a little ball with a spring.
Yeah.
And if you have too much pressure because it can't force, then you don't want to damage the pump. So it bleeds off some oil through this ball and spring. What happens is the pressure goes too high, it pushes the ball against the spring and it opens a passage that lets some of the oil and pressure go out so you don't break anything.
Okay.
So that's where you get your wear typically, is when you start. Then once you start, if you let it run and it's warm, you don't have a problem, but you're shutting down. This is where you get a lot of that happen.
For more videos like this, please subscribe.